Welcome back, physics fans, as we continue on here with example number 6. This is another static equilibrium one. If nothing is moving, we have a beam hanging out from a wall. There's a tension in the cable holding it up, and there's a 25 kilogram sine off of it. So here it is, the description of the question. The mass of the beam is 10 kilograms, and the length of it is 6 meters. The cable is attached to the beam at a point 4 meters. That's hard to see, so I'll highlight it because it doesn't look like a number. It's all spelled out. 4 meters from the wall. There is also a 25 kilogram sine hanging from the end of the beam. Determine the tension in the cable, and eventually we'll look at the forces from the hinge, but we're going to just really focus on getting that tension in the cable right now. Okay? To solve the beam problems, we're going to apply the two conditions for static equilibrium. In the torque equation, it is usually best to select the hinge as the pivot point. This makes the forces that the wall will have equal to 0, the torques equal to 0. So if I had to draw a free body diagram for it, and I'm doing it for you first to help you, there is the beam, there's the sine pulling it down, there's a center of gravity pulling it down, the tension pulling it up, and there is some unknown force here that's from the wall. There's definitely a force this way pushing it out from the wall, because if that wall was glass, it would go right through that wall, right? And then there's probably an upward component or a downward component, and it's hard to tell even right now. Maybe it's absolutely balanced, but I would doubt that. But if I pull this pin, it might swing up, because this is pretty darn heavy. So there's an upward force component and a horizontal force. We don't know what that is. So draw it, guess. It could be totally wrong in your free body diagram. And that's what I did. I said it probably is something like that. But that is the exact reason why we're going to put the pivot point right there. Not that it gets rid of that force in our translational formulas, but it gets rid of that torque in the rotational formulas. And that's what I just described here. So the sum of the torques equals 0, and we're putting the pivot point at the hinge. So the torques counterclockwise equals the torques clockwise. The torques counterclockwise is just the tension force. See, the tension force is causing it to go up that way. And the other ones are doing it clockwise. So the torque caused by the tension is equal to the torque caused by the cog plus the torque caused by the sine, S-I-G-N. Okay, so now we start filling it in. Although, please, when you're doing your own, you have to write all this down. It's an art form, how to do this science. So the torque caused by the tension is force distance sine of theta, right? The torque formula is FD sine theta. So this is going to be tension times the distance times the sine of theta. And that equals the force of gravity of the cog. I guess force cog would probably be better, because the cog already has center of gravity in it. Times the distance times the sine of the angle. But that one is going to be 1 because it's at 90 degrees right there. I just ruined my free body diagram by putting a right angle in there, but so I'll take it out. Plus the force of gravity of the sine times its distance times the sine of that angle. but the sine of that angle is also going to 1. I mean, theta is 90. So tension, plugging in the numbers now. How far is that rope from the pivot point? It's 4 meters. What is the angle that that tension comes to the beam at? There's our radial arm, and there's the tension. So the angle is 35 degrees. And that equals the center of gravity, the force of the center of gravity. Well, we were told that that beam is 10 kilograms, and it's 6 meters long. So it's 10 kilograms times 9.8, and it's times 3 meters, half the length of that beam. Plus the force of gravity of the sine, it's 25 kilograms times 9.8, and it's all the way to the end of that beam, so that's 6 meters. Okay, that, my friends, my students, that is definitely a B right there. If you just walked away and went to the next question, that's a B. You've done almost all of it except for now just the math. So 10 times 9.3 times, 10 times 9.8 times 3 is 294. Six times 25 is 150 times 9.8 is 1,470 Newton meters. On the left side here we have T, and then we have 4 times sine of 35, and that's 2.294 meters. So this is 1764 Newton meters. So the tension is just going to be equal to 768.8 newtons. There we go. I'll just leave it like that. I'll just put this short little video up on this one doing number 6. If you have any questions, leave them in the comments down below. Subscribe, like. Okay, then don't subscribe. Fine.